Yes, I know. So maybe we can start. Yes, do you see the screen properly, all of you?
Yes, sir.
Yes, sir.
Okay, good. Okay, so hello everyone. Yes, I apologize for being late. Okay, sometimes there are phones at inappropriate time and from people from of whom it is very difficult to ignore. Okay, I generally ignore, but okay, today I did not have the courage to ignore the phone. So that is why I got late. My apologies. Okay, so without any further delay, let us start. And let us start as to what we were doing. So what we were doing in the last class was that we had written a generating function. Okay, the generating function for a polynomial is given by, let us say g is some polynomial, then this capital G xt is given by, so if p and x is the polynomial, then this is given by summation p and x t to the power n. So students, see, this is not too difficult to guess what will gxt be. If you know what p and x is, then the infinite series of the sum of p and x multiplied with t to the power n, that will be the generating function. Okay, so what is it? This is like p naught x plus p1x times t plus p2x times t square plus so on. Okay, plus p and x t to the power n. So if you know all these terms, then the summation of all of this will be equal to this. This we know that it is equal to 1 by square root of 1 minus 2xt plus t square. Okay, so this should now not be too magical. Okay, see, I once again tell you, so if you think that this is like magic, then it is not. Why is it not magic? Because this gxt has been obtained by taking the sum of the known terms. We know what p naught x is, we know what p1x is, we know what p2x is. All of this, then the sum of this infinite series is can be written like this. So the only question is whether this gxt is equal to this or not. Okay. This is by definition. Okay, this is by definition. The generating function of a polynomial is defined by multiplying the polynomial with t to the power n and then summing it from n equal to 0 to infinity. That is what is known as generating function. So the right hand side is this plus this plus this plus this and so on. Okay, so if it is so on, then we know that since we know all the terms in this, so that means this should be an overall term that should be a function of x and t. So now our job is to guess, or job is to find what that term is. Okay, so that means now it becomes a research problem as to finding what is the sum of this infinite series. Now the sum of this infinite, whether the sum of this infinite series is this or not is a matter of verification. Okay, so what we did is that we did this sum and we reached at this answer and then we verified it. So that is why this is known as generating function. So in that way, this is not too magical. Okay, what is however magical is that the PLX that we had written, the Rodriguez formula, the Rodriguez formula formula we had derived was 1 by 2 to the power L factorial into dl by dxl of x square minus 1 to the power L. This was the Rodriguez formula, right? You remember?
Yes, sir.
Yes, are some of you here?
Yes, sir. Yes, sir.
Yes. So, yes, this you can say is some kind of Rodriguez formula. As to means how did Rodriguez came up with this x square minus 1 to start the derivation of this PL of x? Because once you know the general formula for this, then you can put all those values in this and then it will be an infinite series which is a function of x and t. So that infinite sum can be written as some function of x and t. What that function is we do not know, but then means this is the job of researchers, let us say, to find what that function is. There are a set of researchers who found that this can be equal to this. Okay, but one series summation, one infinite summation can be done in different ways. So you should not be surprised if tomorrow you get some another generating function for Pn of x. Okay, yes, this formula is slightly magical in the sense that we started with this and then when we did the dl by dxl of this, we found a function which obeys Legendre's equation. And then we said that that function is proportional to PL of x. The proportionality constant came out to be 1 by 2 to the power L into L factorial. We will talk about the derivation of this. Okay. Once we finish the associated Legendre function, after that we will talk about how people arrived at this. So arriving at Rodriguez formula. So Rodriguez formula is kind of the most fundamental formula. Okay, so given a function, given a polynomial, given a differential equation, you can guess as to what will be the Rodriguez formula. Okay, I will give you a formula. So for all the Legendre equation, so then you can, from that formula, you can guess whether this is the correct formula or not. Okay, so there is a general form of y of x or PL of x, because y of x will become PL of x in case of Legendre polynomial. Y of x will become Hn of x in case of Hermite polynomial. It will become J alpha of x in case of Bessel function and so on. So there is a general form of y of x that we shall be interested and we shall be calling that the Rodriguez formula. Okay, but once we get the Rodriguez formula, then this infinite sum on the left, on the right hand side will give us some function that we will call the generating function. And in case of Legendre's polynomial, it just happens that this infinite sum comes out to be this. This we verified yesterday, that this is actually equal to this infinite sum. So are you now a little bit out of that magical word? Tell me.
Yes, sir. Comfortable, sir.
Yes?
Yes.
Yes, good. So if that is good, then we know, then by now we have understood as to what the generating function is. Then the next thing that we did is that we took some time derivative and the space derivative of this generating function. And then we derived something that is known as recursion relation. Okay? The physical meaning, the physical significance of recursion relation was that we do not need to remember this formula to calculate PLX anymore. Okay? With some knowledge of P0 x and P1 x, we can actually calculate what P2x will be. Similarly, with knowledge of like two values of P of x, two different L values of P of x, we can obtain the third value of PL of x. Okay, so for example, from P0 and P1 we could calculate P2. From P1 and P2 also we can calculate P0. From P1 and P2 we can calculate P3 and so on. That was the power of the That was the power of the recursion relation. So can you please help me write the recursion relation one more time? So the recursion relation that we had was n plus 1 p n plus 1 x. I'll write one. We will take one example and then finish. P n plus 1 x minus 2, okay, sorry, plus n p n minus 1 x plus n p n minus 1 of x plus, sorry, minus 2n plus 1 x p n x minus 2n plus 1 x p n of x is equal to 0. I hope all of you are confident of the derivation of this relation. Yes, we discussed this term by term in yesterday's class. Is that all right? Yes? Yes, students?
Yes, sir.
Yes. Okay. So that is all right. Then from the one of the outcomes of this relation could be that we already know that P naught x is 1 and P1x we know is, what is P1x? P1x we know is x. So let us calculate as to what P2x will be. Okay. So we take n is equal to 1. So for n is equal to 1, this relation becomes 1 plus 1, which is 2 times P2 of x plus n is equal to 1. So 1 times P naught of x minus 2n plus 1. 2 into 1 plus 1 is 3x times Pn. N is 1. P1 of x is equal to 0. So for n is equal to 1, this is the relation that we find. We already know what is P naught x and P1x. So let us see what is P2x. So P2x from here will be, this term will remain on one side. So P2 of x will be equal to 1 by 2 times, this P naught x will go to the other side and become minus P naught of x. So this is P naught of x we know is equal to 1. So this will become minus of 1. This 3x times P1 of x will go to the other side and become plus 3x P1x. P1x we know was x, so this will become 3x square. And see, P2x was actually 1 by 2, 3x square minus 1. Yes? So without actually calculating what is P2x, from this relation we have obtained what P2 of x will be. Now that you have obtained P2 of x, you can put n equal to 2 and obtain what will be P3 of x. Because for P3 of x, you need to determine n equal to 2. So that means you need to find what is P1 of x and then what is P2 of x. P1 of x is equal to this, P2 of x is equal to this. So P3 of x can be determined. Okay, as a function of x. Are you all happy with this? Tell me. Yes? Bully students. Yes, is this all right?
Yes, sir.
Yes? Okay. So if this is all right, then what we do is that we go to the next step. And now, yes. So this we have obtained. I think I had given you the homework of revising the recursion relation, the second recursion relation. So I will not derive the second recursion relation. The second recursion relation tells you that from the knowledge of the derivative, the x derivative of one of the Legendre function, you can obtain the x derivative of another Legendre function. Okay? So just like it was a relation between Pn plus 1, Pn and Pn minus 1, similarly you can obtain a relation between P dash n plus 1 and P dash n. Okay? So from one value of one functional form of Pn, you can obtain the previous or the next functional form of the Legendre polynomial. Okay? So that is what is given by second recursion relation of the Legendre polynomial. We go back a little, and now that we know revisit the orthogonality relation. If you remember, we had obtained -1 to 1 PLX PMX dx. It was equal to some CL delta LM. Do you remember you had some relation like this? Tell me. Yes, speak a little louder.
Yes, sir.
Yes? Okay. So today the volume seems to be a little less. So I cannot hear it. Just a moment. I hope it has improved. The volume has improved. Oh yes, I think now it has improved. Yes. So this was the relation which we had obtained. However, we still do not know what CL is. For when L is not equal to M, we know that this side will be equal to 0. Let us calculate as to what CL is when L is equal to M. So when L is equal to M, then it will be, so L equal to M is what we try to calculate. So this is P -1 to 1 PL of X times PL of X dx. This we know is C of L. Okay, this is some constant CL. Let us try to calculate what is the value of this C of L. Okay, so for this also, we know that PL of X. Okay, so the way we do it is that we start with the generating function. So you tell me what is generating function? So how do you write it? We write it like 1 minus 2xt plus t square to the power 1 by 2. This we know can be written as PL of x t to the power L. कैसे लिखा जा सकता है बच्चे ये? This can be written as PL of x t to the power L. है ना? लिखा जा सकता है कि नहीं? You tell me. Students.
Yes,
please,
sir.
Yes. So please be a little responsive. Okay. So now we try to write this. Okay. So in this we know that there are two PLs that are involved. So if there are two PLs that are involved, that means we need to take a square of this. So this implies that if you take a square of this, then this will be like this. Yes? If PL to the power L was 1 minus 2xt plus t square to the square root, then the square of this will be equal to this. Okay? So this is all going from L equal to 0 to infinity. है? So now we need to take a -1 to 1 and dx of this. Okay? हमने क्या करना है इसका बच्चे? We have to take a -1 to 1 dx of this. Okay? So, okay, I write the right hand side once again. So this is because this summation is over, integration is over x, summation is over L. So the summation sign can come out. So this is L going from 0 to infinity -1 to 1 PL of x square dx times t to the power L. 2L, I'm sorry. We have taken t to the power 2L outside the, let us say, integration. Why? We can take it because t is independent of x. T and x are two independent variables. Are you getting it?
Yes, sir.
Yes? Okay, good. So then what we do is that we know that this is the thing which is equal to this. So this is the thing which we need to calculate because this thing is equal to CL. Okay? So that means we definitely need to calculate as to what is this. So if you want to calculate this, then the simplest way which you have learned in like your high school was that take 1 minus 2xt plus t square equal to some p or maybe y. What do you take? You take 1 minus 2xt plus t square equal to some y. So then this implies dy. What will be dy? We need to change it in terms of x. Okay. So initially it was a function of x. We are from x we want to go to y. So what will be y? Y will be minus 2t dx. Oops. Dx. Right? Because we only want to go from x to y. Okay. So the only dependent variable is x. So dy will be equal to minus 2t dx. Is it alright?
Yes, sir.
Yes? Shabas. So dx it implies will be equal to minus 1 by 2t. Correct? Okay. Let us change the limit. So what will be the lower limit? The lower limit was x is equal to minus 1. So if x is equal to minus 1, then y lower will be 1 minus 2 times minus 1, which will be plus 2. 1 plus 2t plus t square. 1 plus 2t plus t square we know is equal to 1 plus t square. Correct or not?
Okay,
Yes?
sir.
Yes, Shabbat. The upper limit was plus 1. So if you put x is equal to plus 1, then it is like 1 minus 2t plus t square. What is 1 minus 2t plus t square? 1 minus t whole square. So that y minimum is 1 plus t square, y maximum is 1 minus t square. Are you all happy with this? Yes?
Yes, sir.
Sir.
Yes. Shabbat. So then there was a minus 1 by 2t dy by y. Correct? Tell me. Yes. So this thing is equal to this. Okay? So this dy by dy we know is logarithm of y. This 1 by 2t can come outside the integration because 1 by 2t is independent of y. So the answer that you get is minus 1 by 2t. Logarithm of y will be logarithm of the upper limit minus logarithm of the lower limit. Okay? But logarithm of m minus logarithm of n we know is equal to logarithm of m by n. Are you okay with that or not?
Yes, sir.
Yes. So this is logarithm of 1 minus t whole square divided by 1 plus t whole square. Yes. So this can be written as like whole square of 1 minus t by 1 plus t. Then logarithm to the power comes in front. So this 2 will come in front. Okay. So this 2 will anyway cancel this 2. There was a minus sign here because of the minus 1 by 2t factor. This minus sign will you can say this minus sign will go here and it will reverse it. So this term will be equal to logarithm of 1 plus t divided by logarithm of 1 minus t. Okay, sorry, logarithm of 1 plus t by 1 minus t. Tell me if this is alright with you or not. Into 1 by t. Yes, ask me anything. This 1 by t is from here. This is 1 by t. Logarithm of this is ulta. This is ulta of this. We have done it ulta. We have done it reverse because there is a minus sign over here. Happy everyone?
Yes, sir.
Yes.
Yes, sir.
Shabas. Yes. Shabas. Now this is logarithm of m by n. Logarithm of m by n we know is logarithm of m minus logarithm of n. So now you please tell me what is the formula for logarithm of 1 plus t? Tell me, all of you. Logarithm of 1 plus 2 is t minus t square by 2 plus t cube by 3 minus t4 by 4 plus t5 by 5 and so on. Similarly, instead of t you put a minus t. So this will be 1 minus t. So this will be, wherever there is a t there will be minus. So this will be minus t. This minus and this t square. The minus t will be compensated by this t square. So the second term will also be minus t square by 2. The third term will be minus t cube by 3. The fourth term will be minus t4 by 4 and minus and so on. Are you happy with these two terms?
Yes, sir.
Yes. So logarithm of 1 plus t by 1 minus t, which is the difference of these two. So if you take the difference, then what will happen? Tell me. This even powers will be cancelled. If you take the difference of this and this, then the even powers will be cancelled. What will be remaining is that this is t plus t, which is 2t. This will be t cube by 3 plus t cube by 3, which will be 2t cube by 3. So I write this as, देखिए एक बार मैं इसको यहाँ पे लिख देता हूँ बच्चे. You can see this logarithm of 1 plus t by 1 minus t. This will be equal to 2 common t plus t cube by 3 plus t cube by t5 by 5 and so on, plus so on. Please see this. This is very important. Are you happy with this? Yes.
Yes, sir.
Yes, Shabas. Now, the left hand side was 1 by t of logarithm of 1 plus t by into 1 minus t. So, that is we take a 1 by t into this. This is outside the logarithm. So, if you take a 1 by t, then you know that this t will be gone. This t square will become t cube will become t square. This t5 will become t4. And all of this will become t raised to power 2n divided by 2n plus 1. Are you all happy with this? Tell me.
Yes, sir. Yes, sir.
Yes, sir.
Yes? Shabas. So we write this particular series as a summation over here. I remove this particular line from here and rewrite the left hand side. So I remove this and rewrite the left hand side as 2. I write it once again, please. 2 into 1 plus t square by 3 plus t to the power 4 by 5 plus so on. So I write this as summation n going from 0 to infinity. This is an infinite series. So this is like 2 2 and then what will it be? This will be t to the power 2n by 2n plus 1. You tell me whether it makes sense to you or not. If it doesn't, you please ask me. I will explain it one more time. बताइए.
Makes sense, sir.
Make sense? All of you? Yes.
Yes, sir.
Yes.
Yes? It makes sense to everyone, right? Shabas. So if it makes sense to everyone, then we have unlocked the code. So see, this is equal to this. So that means this is equal to this. Okay. So this n could have been L, let us say. तो समेशन ही तो था ना. So समेशन में हम क्या कर देते हैं? समेशन में n किस जगह L रख देते हैं. So what? So now this term can be compared to this term because this was our right hand side. So because this is a series in L and there is a t to the power 2L here as well as here. So that means you can compare the coefficients of equal powers of t. So if you compare the coefficients of t to the power 2L on both sides, then the coefficient of t to the power 2L on this side is minus 1 to 1 PL square dx. Whereas the coefficient of t to the power L on this side is 2 by 2L plus 1. This quantity we know was equal to CL. What was this PL square dx between minus 1 and 1? This quantity we know was equal to CL. So this implies that this CL is nothing but 2 because 2 is the coefficient. 2 divided by 2L plus 1. Students, this is one of the most important results that you will find. Okay? So, this gives you the overall orthogonality relation. It tells you that the integration of PLX, PMX, dx between minus 1 and 1 is nothing but 2 by 2L plus 1 times delta ln. If you have any doubt in this, you please ask me. What will it be? This will be PLX, PMX dx equal to 2 by 2L plus 1 into delta ln. If L is not equal to M, this term is 0. If L is equal to M, this term we know. So what will be, for example, P7x dx between minus 1 and 1? That will be equal to 2 by 2 into 7 plus 1. So that means that term will be equal to P 2 by 15. You can calculate, you can do the integration of P73, P73x, P73x, P73x dx. The answer will be 2 by 147 because 73 2s are 146 and then that will be 146 plus 1 will be 147. Ask me any question on this. This is the most general form of orthogonality relation for the Legendre polynomials. Yes, are you happy? So in order to obtain this, we took the help of generating function. So that is why generating function is so helpful. Generating function is used to calculate the recursion relations. Generating function is once again used to calculate the orthogonality relation. Happy everyone?
Yes, sir.
Yes, sir.
Yes. Okay,
Yes,
good. Very good. Okay. So if you are happy with this, so that means you can calculate any integration. So अगर आपको अभी एग्जाम में कोई क्वेश्चन आ जाए, then tell me what is. So the question that you might be asked is that okay, tell us what is P17x, P33x dx. And the second question that you get is P37x, P37x dx between minus 1 and 1. Both of them between minus 1 and 1. So this from the orthogonality relation you can say will be equal to 0. This from the means you do not need to calculate the integral explicitly. From the orthogonality relation you can say that this will be equal to 2 by 2 into 37 plus 1. So that is 2 by 75. You can also calculate it now explicitly. That means you can, what is P37 of x? P37 of x is a polynomial which has 37 power of x. So you write the 37 power, 36, 35, 34, 34, all those terms you write. you take the square of that term, then you integrate it between -1 and 1. The crazy answer that you will get will be 2 by 75. Happy, all of you? Yes.
Yes, sir. Yes,
Yes,
sir.
sir.
Yes.
Sir.
Yes, very good. Okay, so I'm also very happy if you people are happy. Okay, good. So if we have done this, then that means we have learned almost all the stuff that is related to the Legendre polynomial. Okay, I will request you. Okay, this is not even a request. This is that I will give you the Rodriguez formula for one of the polynomials. So let us say Hermite polynomial. So this is now, what is it? Assignment.
Sir, can I ask a question?
फिर से बोलिएगा please.
Sir, can I ask a question?
Yes, please. All the questions. Yes, please.
सर एक्चुअल में ये जो ऑर्थोगोनैलिटी है सर, जैसे हम क्वांटम में भी यूज करते हैं या फिर मैथ्स
Yes.
एमएमपी में भी यूज कर रहे हैं,
Yes.
तो एक्चुअल में इसको हम फिजिकली कैसे रियलाइज करेंगे कि ऑर्थोगोनैलिटी का एक्चुअल मतलब क्या है?
Orthogonality
क्रोनिका
का meaning क्या है,
रिलेट
right?
करते हैं.
Yes, exactly. Yes. So this is like f of x times g of x dx is equal to 0. This is orthogonal. If f of x, g of x dx is equal to 0 between some limits a and b, then this means that this is orthogonal. This is orthogonal is what we are writing, right? So now the question is as to what is the physical meaning of this? So the physical meaning of this is that within the domain B and C, fx is some function. Okay, so along a particular direction, in this you choose a particular fixed direction. So if fx has some component in that direction which is equal to this, then in the same direction, g of x, the component of g of x will be 0. Okay, I repeat. So f of x is this, let us say. G of x is something which is this. Okay, arbitrary. I have now taken arbitrary. So this is this. We know that these vectors, they can be like added by their tails. So we can write this representation as this and this. Let us say, okay, even though the directions here are different, so this is equal to this. These two vectors are not orthogonal. This is f of x. This is g of x. So this f of x in certain direction. Okay, in the same direction, the g of x has this component. Now we want to know whether f of x and g of x are orthogonal to one another or not. So we take a particular direction and find what is the component. So in this direction, for example, let us choose one particular direction. Let us say this direction is perpendicular to f of x. So in this direction, the component of f of x is 0, whereas the component of this g of x has certain component over here.
Yes, sir.
But there is certain direction over here in which f of x also has some component, g of x also has some component. Okay, so that implies that f of x and g of x are not orthogonal. Orthogonal means that
Means
in the
component
direction. So this is f of x, this is g of x. These two will be orthogonal. Why? Because the component of g of x in the direction of f of x is 0.
so we can say that the components of two functions do not superpose each other.
This implies that there is no component of p33 of x which is
Yes,
in
sir.
the direction of p17 of x.
Yes, sir. Yes, sir. Yes, sir. I got it.
Yes. Right? So this implies that there is no component of p17 of x which is in the direction of p33 of x.
Yes, sir. Clear, sir. Yes, sir.
Yes,
That is what I want.
correct. They
Yes,
they
sir.
are, of course, because they are same, so they need to have common components. So they need to have common components. The what is it? The expectation value of that component is 2 by 2n plus 1.
Yes, sir. Clear, sir.
Integration, it gives us some kind of expectation value, you know. You know? This integration is something like this, right? AB. Yes, AB
Yes,
is
sir.
written as A of x, B of x dx. That's it. And this we know is some kind of inner product or expectation value.
Yes, sir.
Are you okay with this?
Yes, sir. Yes, sir. I know, sir.
Yes. So this is what is the orthogonality. So if A and B are orthogonal, then this is equal to 0.
Yes, sir. Okay, sir.
Correct?
Yes, sir. It is clear. It is
Yes.
clear now.
Yes. All right. Good. Any other question?
No, sir. It's all
No.
right.
Then I erase this and I give you an assignment. Okay. So the assignment is that calculate the recursion relation and orthogonality relation for number 1, number 2, number 3. How many students are there in your class?
45, 44,
Excuse me?
44 or
44.
45.
44 or 45.
Probably.
The first 15 roll numbers. First 15 roll numbers. Then the next 15 roll numbers. And then the last 14 roll numbers. The first 15 roll numbers will give me the recursion relation and orthogonality relation for Hermite polynomials. रोज अगर इसमें प्रिंट करना प्लीज ये फ्रिज पे रखा है okay so the first 15 roll number of your class will do the recursion and orthogonality relation for Hermite polynomials. If you do not see your roll number, then you please tell me. I will repeat what you need to do. The next 15 roll numbers will do that. What is it? The Legendre polynomial. And the last 14 roll numbers will do it for the Bessel's polynomial. You can, all the three groups can start by taking the generating function for the individual polynomials. Okay? आप सब लोग क्या कर सकते हैं? You can start your exercise by taking what is the form of generating function for all these polynomials. Starting from the generating function for these polynomials, derive the recursion and orthogonality relation for Hermite, Legendre, and Bessel's polynomial. I hope this work can be done in 10 days. Okay, so the due date for the assignment one Sunday which is coming in 2-3 days, and there is another Sunday which is coming after that. When is that Sunday? The first Sunday of June. Okay? This is it. Please try to spend your own time calculating this. If you do not understand anything, you please discuss in the group. Okay? If you are not able to get something by yourself, you please ask me. Okay? Is the assignment clear to everyone?
Yes, sir.
Yes, sir.
You have to do only one question. Either you have to do this, or you have to do this, or you have to do this. Alright? Yes?
Yes,
So
sir.
this should be broadcast to the people who are not attending the class also. Okay, good. So now we do some magic and we go to the next topic. So until now we have been discussing the Legendre polynomials and the other polynomials. In unit 2, we need to discuss something known as associated Legendre polynomials. So, the associated
Can you do some
associated
examples related to this?
Legendre polynomials. देखिए, we had initially started with the associated Legendre equation, but right at the first step we had assumed that the m that was appearing in the associated Legendre equation, that was equal to 0. And when m in the associated Legendre equation was equal to 0, then we had said that if m is equal to 0, the associated Legendre equation becomes equal to Legendre equation, and we had discussed only the Legendre equation after that. However, understanding associated Legendre equation is one of the points in our syllabus. So since it is explicitly mentioned in our syllabus, it is our duty to understand as to what that associated Legendre polynomial is. Okay, so keeping that motivation in mind, in today's class we will start by writing explicitly what is the associated Legendre equation, and then what is the solution of that. So for example, the solution of Legendre equation we had derived was PL of x was 1 by 2 to the power L factorial dl by dxl of x square minus 1 to the power L. This was the y of x, or this was the solution of the equation 1 minus x square d2 by dx2 of plx minus 2x d by dx of pl of x plus l into l plus 1 pl of x equal to 0. So if this was the differential equation, then by our power series method we had seen sorry, then by power series method we had seen that what did we see? Yes. So by power series method we had seen that this PLX has to be written like this. Okay? But this was kind of a cheating, because this equation was not only this. There was an additional term over here which was minus m square by x square into PL of x. But that minus m square by 1 minus of m square by 1 minus x square we had draw by assuming m to be 0. Okay, but assuming m to be 0 was a cheating. So what we will do is that we will accept that it was a cheating, and then we will write the general equation over here and try to solve as to what is the solution of that equation. So the problem that we are going to solve is we are going to start that right now. Can I erase all of this? Yes.
Yes, sir.
Yes. Okay, good. So I hope the assignment is clear to everyone. Okay, good. So देखिए बच्चे, what we need to calculate is we need to calculate our equation was d by dx of 1 minus x square d by dx of y plus q minus m square by 1 minus x square of y is equal to 0. This equation, if you remember, was called an associated Legendre equation. However, we put m equal to 0 and then it becomes the Legendre equation. And in Legendre equation, one more thing that we know is that this q also came out to be L plus 1 into L. I need to have some water. Plus 1 So the y in this can be called y associated Legendre.
Sir, video is off.
Capital A, capital N. This y can be called capital A, capital N.
सर
At the same
वीडियो नहीं आ
time,
रहा
this
है.
is y associated Legendre.
Sir, video is
However,
off.
we
Sir,
did a
video
trick.
is off.
We played a trick and we put m equal to 0. And the equation that we told was this d by dx of 1 minus x square dy by dx plus L into L plus 1 y is equal to 0. This equation we explicitly solved. But since we have put m equal to 0 in this, we do not call this y as yal. Rather, we call it as yl. Okay? And this yl is what is called pl of x. So, equation 0 is our mother equation. Okay? Equation 1 is the daughter equation. So, daughter equation we have studied in detail. However, we need to study mother equation also. Okay? So, now the problem is, now the question is, how do we get what YAL is? And the first answer we give is that it is almost difficult, almost impossible to solve this equation from that first principle. So we once again take a trick path. Okay? What we say is that since we know that this equation has particular solution, we do not know what y of AL is. This we do not know. This is some power series that we know, but what is that particular power series we do not know. However, here in this case, YL we know that this is equal to 1 by 2 to the power L factorial and then DL by DXL of x square minus 1 to the power n. This we know. This we have spent like enough hours understanding how we got this. Yeah? So our aim in today's class will be, this will be like a cheating game, but the aim will be to go from this PL of x to this YAL. And since this YAL equation contains L and M both, so this Y will also be called PLM of x. Just like this YL was called PL of x because it only contained one L. Since this equation contains L and M both unknowns, okay, so this solution YAL will also be written in literature as PLM of x. So our aim in today's class will be to obtain what this PLM of x is, given that we know what PL of x is. Is the problem clear to everyone? Students,
No, sir.
no?
So can I,
What is not clear? Tell me. Okay, you know what is the solution of this equation.
Yes, sir. Yes,
Yes.
sir.
So this you know, right? This you know that this is the solution of this equation. We do not know what is the solution of this equation. Enough? So our aim will be to know what is the solution of this equation. Okay, so that is the problem. Okay?
Yes, sir.
Yes. So the tackling, the way we are going to tackle, the way we are going to find this is via our knowledge of the solution of number 1. The way we are going to get the further information is via the information of the son. Okay, so this is the previous generation information is obtained. We will be attacking the problem to obtain the information about previous generation with our knowledge of the information of the current generation. So let us solve it. So solve, solution. Solution says that we do not start with equation number 0. We do not even know whether equation 0 exists in this universe or not. Okay, so we are ignorant. We do not know whether this equation exists. What we do is, we know that equation 1 exists and it is known as Legendre's equation. So we will start with equation number 1 only. And we will differentiate equation number 1 m times with respect to x. हम क्या करेंगे बच्चे? हम करेंगे कि भाई जो हमारा ये इक्वेशन नंबर 1 है ना, इसको हम क्या कर देंगे? इसको हम m टाइम्स डिफरेंशिएट कर देंगे. ठीक है? So let us differentiate this. Please tell me. Okay, so इसके लिए हम क्या करते हैं? इसको इस टर्म को भी हम दो टर्म्स में लिख लेते हैं. जो ये वाला था ना आपका, this term you know can be written in two terms, right? So the first term here was 1 minus x square d2yl by dx2 minus 2x dyl by dx. ऐसे लिख सकते हैं ना? So अभी इक्वेशन 1 को हम क्या करते हैं? We differentiate it m times with respect to x. So that means we need to determine, but so then we go term by term. So this is like differentiate this sentence, differentiate this sentence, differentiate this sentence, and then add all those three. So we write the first term. First term is d m by dxm of 1 minus x square d2yl by dx2. सो देखिए mth ऑर्डर डेरिवेटिव कैसे निकालना है ये हमने पिछले दिनों में काफी बार डिस्कस किया है. Okay, so this you know can be calculated as summation k going from 0 to infinity m, or not infinity, k going from 0 to m, I'm sorry, m c k, and then the kth derivative of one term and the m minus kth derivative of the other term. यही होता है ना बच्चे. dm by dxm of ax into bx. So a into b. How do you write this? You write this as summation k going from 0 to m, m c k dm minus k by dx m minus k of a times dk by dxk of b. Yes, this is the general formula for the mth order differentiation. Everyone agrees with this, right? Yes.
Yes, sir.
Okay, so you tell me which term shall we take A, which term shall we take B in this? How, which term to be taken K and which term to be taken A and which term to be taken B depends on what is the form of A and B. Okay, so see, the first term here is 1 minus x square. So this term we know will have only finite number of non-zero derivatives. So for example, its third derivative will be equal to 0. So that means this term can be taken in this particular term because k is anyway going from 0 to something. Okay, so when k reaches 3, for example, and b, if b is 1 minus x square, then k equal to 3, this will be equal to 0. Okay, so we take this term to be the second term. This term we take the b term, and this term we take the a term. Okay, so if you take it like this, then you get that this will be d m minus k by d x m minus k of d2y by dx2. d2y by dx2 I have written as, okay, d2yl by dx2. d2yl by dx2. This is term A times dk by dxk of b. What is b? b was 1 minus x square. You tell me if this is not clear to you. बताइए please, all of you. dm by dxm of 1 minus x square d2yl by dx2 we write as summation k going from 0 to m mc k dm minus k by dxm minus k of d2yl by dx2 times dk by dxk of 1 minus x square. Yes, इसको solve करिए. Now our job is to get all these m terms from here. So let us do it. So this will be, the first term will be k equal to 0. MC0 we know is equal to 1. Then dm minus k by dm minus k. So this will be, because k is equal to 0, so this will be like dm. So dm by dxm of d2 by dx2yl will be equal to dm plus 2 by dxm plus 2 of y yes, of YL, that will be this times this. So d0 by dx0, 1 minus x square. We know it will be equal to 1 minus x square. Because zeroth derivative of the function is function itself. Okay, so we have taken care of the k equal to 0 part. Then the second part will be plus. Now the term is k equal to 1. So what is k equal to 1? MC1. What is MC1? Tell me.
M.
M. MC1 is equal to M. Then this is d m minus 1 by dx m minus 1 acting on d2 by dx2. So that means this all of this will combine and it will give you dm plus 1 by dxm plus 1 of yl. Yes? Times d by dx of 1 minus x square. What is d by dx of 1 minus x square? D by dx of 1 minus x square is minus 2x. What is d by dx of 1 minus x square? Is minus 2x. So this is minus 2mx. I write it properly. Minus 2 times m times x. Is it okay with everyone?
Yes, sir.
No,
Yeah.
no, no, sir. Sir,
No?
sir, after kth derivative, 1 minus x square will be 0,
No.
isn't it?
No. K is equal to 1. K equal to 0 term is this. K equal to 1 term is this.
Okay, sir. Then okay.
ये ठीक है कि नहीं है?
Yes, sir, ठीक है.
ठीक है ना? Okay, this
Yes,
is
sir.
correct. Now k equal to 2. So see, we have written the k equal to 0 term, k equal to 1 term. Now we are going to write the k equal to 2 term. So in the k equal to 2 term, we first take care of this. d2 by dx square of 1 minus x square. What will be?
Only minus 2.
What will be? So this will be like d by dx of minus 2x. है ना बच्चे? And d2 by dx2 of 1 minus x square will be d by dx of minus 2x, which will be equal to minus 2. Are you getting me or not?
Yes, sir.
Yes? So this is minus 2. This minus 2 has come because of this d2 by dx2 of minus 1 minus x square. Happy everyone?
Yes, sir.
Yes. Now we calculate this MC2. What is MC2? MC2 we know is m factorial by 2 factorial into m minus 2 factorial. What is MC2? MC2 is m factorial by 2 factorial into m minus 2 factorial. And then we calculate this dm minus 2 by dx m minus 2. And when it combines with d2 by dx2, it becomes dm by dxm. So I write this as dm by dxm of yl. All of you, please tell me if anything is not clear in term number in the mth derivative of term number 1. The box quantity is the mth derivative of term number 1. बताइएगा अगर कोई चीज क्लियर नहीं है तो आपको सबको ठीक है ना?
सर ये साइड में क्या लिखा है, बिल्कुल राइट साइड में थोड़ा बोर्ड विजिबल नहीं है तो स्क्रीन में आ नहीं
सर
रहा।
आउट ऑफ रेंज आ रहा है सर बोर्ड.
Hold on. So is the okay? Oh yes, I agree. Is it all right?
ये सर
Yes sir.
Yes.
Yes sir. Okay sir.
Good. Okay, so you please see the last term, the term which you are not able to see. This is minus 2m factorial by 2 factorial into m minus 2 factorial into dm by dxm of yl. Okay, we know that this minus 2 has come from the second derivative of 1 minus x square. This m factorial by 2 factorial into m minus 2 factorial has come because of the mc2 term, and then the dm by dxm has come from the dm minus k by dxm minus k of d2 by dx2. Happy everyone?
Yes, sir.
Yes, students.
Yes, sir.
Is it all right?
Yes, sir.
Yes. Okay. So now we go to the second term. So see, this is a huge one. Come on, you keep sitting the whole day trying to calculate this term, this term, this term. Only then you obtain these terms. Otherwise, you stare at the book and then you get the answer. Right? So mathematical physics, that is not easy. That way nothing is easy. Means okay, in order to like have the next day, you need to wake up in the morning. Come on. Okay. Let us take the second derivative of the mth derivative of this term. So second term. Second term is dm by dxm of, okay, let us ignore the minus sign for the moment, because minus sign, then we will write the first term minus second term. So let us write it as 2x dyl by dxl dx. Okay, यहाँ पे आप एक बार फिर से you take this x to be the second function. Okay, take dy l by dx to be the first function. So if you take it to be the first function, then we know that this is like, हम इसका इक्विवेलेंट लिखते जाते हैं बच्चे, second function into the mth derivative of the first function. So this is second function was 2x. The mth derivative of the first function is dm plus 1 by dx m plus 1 of yl. सबको समझ में आया ये टर्म? This term for this is equivalent to this term for this. Happy?
Yes, sir.
Yes? Is it okay?
Yes, sir.
Why not? I cannot hear. Why not? Please tell me what is the problem. देखिए ये 1 minus
No problem, sir.
पहले वाले में 1 minus x square is equivalent to 1 minus x square. Here we have 2x. So instead of this 1 minus x square, we put this 2x. Then this was, there was a second derivative. Now this is m plus 2 derivative. There was a first derivative over here. Now this is m plus 1 derivative. Happy, right?
Yes, sir.
Yes, very good. Oh yes, this pen was causing some problem to my ears. Okay, so this is okay. Now we go to the second term. So in second term, we know that we have obtained this minus 2x by taking the first derivative of this 1 minus x square. So the equivalent to minus 2x here will be the first derivative of 2x, which is equal to 2. So this is plus 2. तो माइनस 2x की जगह यहाँ पे बच्चे 2 आ जाएगा आपका. Yes, and then there is this m. This m will also come over here. Okay, and then there is this m minus 1th derivative of the second derivative, which gave you m plus first derivative. Now this is m minus 1th derivative of this first derivative, which will give you the mth derivative. So this is dm by dxm of yl. Please tell me if there is some problem in this. बताइए बताइए बताइए.
सर एक बार रिपीट करना ये डीएम वाला.
ये वाला टर्म.
नो सर, डी रेज टू पावर एम, सेकंड टर्म सर, आफ्टर 2m.
This one, this term,
Yes,
right? Okay,
yes
देखिए,
sir.
we take the help of this. The second term was k equal to 1. MC1 was m over here. है ना? And then d1 by dx1 of 1 minus x square. d1 by dx1 of 1 minus x square was minus 2x. So this minus 2mx came from this and this. है ना? यहाँ पे.
Yes sir.
Okay. And then this. So k was equal to 1. So m minus 1, m minus 1. And this m minus 1 acts on the d2 and dx2. So m minus 1 plus 2 will be m plus 1.
ठीक है सर, ठीक है, आगे समझ सर, आ गया.
अभी ये भी समझ में आया ना आपको?
यस सर, आ गया.
Okay, good. Now, will there be some third term? There will be no third term because in third term here we got 2, which was the second derivative of this 1 minus x square. Whereas the second derivative of 2x is 0. So we do not have any third term over here. So this once again is the second term. Okay, now we have the third term. Third term of this equation, whose mth derivative we are taking. So this is L into L plus 1. So this will be outside and then you take the mth derivative of YL. So the third term will be L into L plus 1 dm by dxm of y of n. If you face any problem in this, you please let me know. Third term was this. What are we supposed to do? We are supposed to differentiate this m times with respect to x. We did. Everyone okay with this?
Yes, sir.
Yes? Now, yes? Now
Sir,
we
I have a doubt.
Yes?
Sir, can you please once again repeat how we select the first and second term? Actually, my connection was lost when
Okay.
you were.
No problem. So see, dm by dxm of a multiplied with b is summation m, k going from 0 to n, mc k dm minus k by dx k m minus k of a and then dk by dxk of b. This is the general formula, student. Okay? ये आपका सबसे जनरल फॉर्मूला होता है mth डेरिवेटिव. Okay? So now a b we had 1 minus x square and d2y by d2yl by dx2. So the question is, which one of these should be a and which one of these should be b?
Yes, sir.
This k, so the second term is starting from the 0th derivative, then the next term will have first derivative, the next term will have second derivative and so on. Suppose m is equal to 100, then this is like the 100th derivative, then the next derivative of a will be 99th, then the next derivative will be like 98th. है ना? So हम क्या करते हैं? Now we use our brain and we say that this is 100th, this is 0th, this is 99th, this is 1th, this is 98th, this is second.
Yes, sir.
तो एक का डेरिवेटिव है वो बढ़ रहा है, दूसरे का डेरिवेटिव है वो कम हो रहा है.
Yes, sir.
You can take either of these, but which one will be convenient to you?
Okay.
So the term which will be convenient to you is that you know that the derivatives of 1 minus x square will begin to vanish as soon as d3 by dx3.
Okay, sir.
So that means
Yes, sir.
if we take this term to be the b term, then
Okay, sir. Now clear.
this term will vanish, this particular term will vanish. So that means out of the possible 100 terms, we only need to calculate 3 terms. For this.
Yes, sir. Now it is clear, sir.
Yes. So that is why we got three terms. 1, 2, and 3 terms. Fourth term was 0. Because in the fourth term d3 by dxk, d3 by dx3 of b, which was 1 minus x squared, this became 0. We applied a similar technique in the second term. We applied a similar technique in the third term. So this is L plus 1. I'm sorry. Yes? Okay,
Yes,
good.
sir.
Now we combine these three terms to rewrite the mth derivative of equation number 1. So please cooperate for some more time. And in that time, I write the equation. Maybe I can erase this line. Okay? Yes, because first term is anyway this one. This is first term. Okay, so I would start erasing this line. Okay, so what are we doing? We are differentiating this particular equation m times to obtain this, and this term. So first term, then minus of second term, and then minus of third term. So minus of second term will give you a minus sign over here and a minus sign over here. Minus of this. Okay. So now we need to add first term plus second term plus third term. So let
Why
us
are
do
we
it.
differentiating, sir, m times this equation, sir? What we want to do ultimately, sir?
Right. So the equation number 0 is too difficult to solve. Equation number 0 is our aim. Okay, we want to reach this equation. However, this equation is too difficult to attempt. So what we want is that we want to reach a similar equation like this by taking the mth derivative of this equation. And why do we want to take mth derivative? Because equation number 1 is in our pocket. We know all the things inside out for equation number 1. So it is like, oh, we have free time. We do not know how to do 0. We know how to do 1. So let us, in our free time, let us differentiate it with m times. Yes, it is exactly like what I said. And once you differentiate it m times, then you start seeing magic. Yes, let me see what is that magic. Let me tell you what is that magic. So see, this first term, so let us write these terms. So there is only one m plus 2 derivative that has a coefficient 1 minus x square. So I write it as 1 minus x square dm plus 2 by dx m plus 2 of yl. Okay? Then m plus 1 derivative. There is m plus 1 derivative of yl here. There is m plus 1 derivative of yl here. There is no m plus 1 here. So we combine these m plus 1 derivatives. This was minus 2mx. This is minus 2x. So we take this minus 2x common, and in bracket we get a m from here and a 1 from here. So this is minus 2x times m plus 1 d m plus 1 by dx m plus 1 yn. Happy? This term we have taken care of. This term we have taken care of. This term also we have taken care of. Now we go to this third term on this second term in this, and this first term in this. Why? Because all of these terms contain the mth derivative of y of L. So this 2 by 2 factorial cancels. M factorial by m minus 2 factorial is, let us write this explicitly. So minus m into m minus 1 देखिए बच्चे, this m into m minus 1 is the coefficient of dm by dxm in this term. M factorial by m minus 2 factorial is m into m minus 1. Happy?
Okay, sir. Clear.
Okay. What is the term over here? What is the derivative over here? Minus 2m. So we write a minus 2m. Okay? Oh, so that it does not create any confusion confusion at later stage. We okay. So if we take this minus common, then this will be minus here and this will be plus over here. अब इसे हमने केवल दो टर्म्स लिखे हैं बच्चे, ये भी ध्यान रखना आप, ठीक है ना? है ना? बोलिए बोलिए बोलिए. Minus sign common, so this is m into m minus 1, and minus sign common, so this is plus 2m. है ना? And then minus sign common, so there is a minus sign over here. Minus, this is inside this big bracket, and this will be n into n plus. This big bracket gets closed over here, and outside this big bracket is dm y of L by dx m. बस खत्म. Yeah. You tell me, does it make sense? Tell me if I made a mistake. देखिए, minus m into m minus 1 is coming from here. Minus 2m is coming from here. Minus minus, which is plus L into L plus 1 is coming from here. Happy?
Yes, sir.
Yes, very good. Okay, अभी देखिएगा magic. So this is m into m square. M into m is m square minus m. M square minus m plus 2m, which is m square plus m. So m square plus m can be written as m into m plus 1. Yes or no?
Yes, sir.
Yes.
Yes.
So I will drop this 2m and will change this m minus 1 to m plus 1. And since I have dropped that minus to plus, I will replace this 2m. Okay. So ये minus L into L plus 1, because ये bracket थोड़ा सा गंदा लग रहा है, so I remove this bracket. I remove this bracket also. So inside the bigger bracket, we now have m into m plus 1 minus L into L plus 1. Tell me if it makes sense. Yes?
Yes, sir.
Students, if you are
Yes,
not
sir.
satisfied, you please let me know.
Yes, sir.
Are you happy? If
Yes,
not,
sir.
you please let me know. Tell me. Everyone is happy, right?
Yes, sir.
This is 0. Okay. So since you are happy and we have combined first, second and third term into this equation, I remove the first, second and third term from here explicitly. Okay. I erase this. This goes away. This also goes away, and the third term also goes away. Okay. Now, see, this is two derivatives more than m of yl. This is one derivative more than m of yl. This is m derivatives of yl. So let us be a little poor and write dm of yl by dxm equal to some u. देखिए YL is our PLX. We know everything about YL. So what is dm by dxm of YL? We completely know. So we know completely everything about u of x. Okay. So we rewrite this term. So देखिए, because I do not want to repeat my handwriting, means my hand is hurting. Okay. So I will write this particular term as d2u by dx2. You tell me if you agree or not.
Yes, sir.
Yes?
Yes, sir.
Yes. So I will remove it from here and will write it as d2u by dx2. Okay. Then this term, what shall I write? In terms of u, I want to remove this YL somehow. I do not like this.
DYL by DX.
Say that again.
D,
No.
DU by DX.
Du by dx. Yes. So I remove this term and write du by dx. Okay. Similarly, I remove this dm yl by dxm from here and write a u. And this I write a bit properly. So I write it like plus L into L plus 1 minus M into M plus 1 times U is equal to 0. So tell me if I made some mistake or is it alright? बताओ बच्चे. This equation is what we obtain by taking the mth derivative of the Legendre's differential equation. What is the equation in the box telling us? The equation in the box is the mth derivative of the Legendre's equation, in which u is the mth derivative of the Legendre's polynomial. Legendre's polynomial is in our pocket, so we know everything about Legendre's polynomial. Yes? Say yes and then I give you another magic.
Yes, sir.
Yes? Okay, good. So, because this is very important, I write not here, I write it somewhere over, okay, I remove this. And I write somewhere over here. What is it? U of x is equal to dm by dxm of this y of L. Y of L we know is PL of x. Okay. So, अभी हमने क्या किया है? From equation 1 we have come to a new equation. You can call this equation 1a or you can call it some 1b or you can call it equation number 2. So we have reached equation number 2 by just taking the mth derivative of equation number 1. Now in equation number 2 you do one more what do? You do one more substitution. And the substitution that you make is, this is going to be like a little difficult, but is the last one for the day. So the substitution you make is that you write u of x. Yeah, and you please do not ask me why. We will see why. Yeah. So you do u of x. So what is the first step? The first step is taking the mth differentiation of this. And the second step is that you replace this u, you like make a change of this u to another variable called v. And okay, because we are mean, we write this 1 minus x squared to the power minus m by 2. बच्चे? Okay, this is the last one, I promise. Okay, no more substitution after this.
Sir, to the power minus m by 2.
Minus m by 2, yes. What is it? Minus m by 2. Minus sign. Okay. U of x is 1 minus x square whole to the power minus m by 2 times v of x. That is that we are not satisfied with this equation because this equation doesn't seem to be anything. This seems to be a completely different equation than 0 and 1. थोड़ा थोड़ा ये 0 के जैसा लग रहा है because in 0 equation also we had this term. 0 equation but we did not have this term in equation number 0. Okay, there was only 2x dyl by dx, but here it is 2x du by dx into m plus 1. So this equation number 2 doesn't look like equation number 0. See, what is our aim? We want to know the information about parents from the knowledge of information about kids. From the knowledge of kids, we have been able to reach here, but this is not exactly parents. So what we do is that we now make another change of variables and we change this u to v via this particular relation, and let us check what does this become. You please tell me what will be du by d, because there is a du by dx here, right? So let us check what is du by dx. Please tell me. Okay, oh, now you people will start shouting. Please tell me. This is, let us take this to be the first term. So this is 1 minus x square to the power minus m by 2 into v dash of x. V dash of x is like dv by dx. Okay, plus d by dx of this into v of x. But what is d by dx of this? What is d by dx of this? Tell me. Minus m by 2 times 1 minus x square minus m by 2 minus 1 times minus 2x times v of x. बच्चे बताइएगा अगर आपको ठीक से नहीं लगा तो. Is it okay?
Yes, sir.
Fine, sir.
If it is okay, then this minus sign takes care of this minus sign, this 2 takes care of this 2. Okay, and this x from here it comes to here, and this is vx comes a little closer. बोलिए बोलिए, आपको समझ में आया कि नहीं आया बच्चे?
Yes, sir. आ गया sir.
शाबाश. Last derivative that I promised for the class, this of this class. So now we calculate what is d2u by dx2, because we need to calculate d2u by dx2 over here, है ना? So let us do. ये हमने सब सही लिखा है ना बच्चे? देख लो आप, अगर इसमें कोई गड़बड़ हुई ना, then we are stuck. Please check. So this is the first term, derivative of second plus second term derivative of first. I think this is all right. Yes. Tell me.
सही है sir.
सही है? Okay. So please tell me what is d2u by dx square. Okay. Let us take this once again to be the first function. So this is v double dash x times 1 minus x square to the power minus n by 2. And then we take v dash x into d by dx of this. But d by dx of this we had calculated over here. Do you know?
Yes, sir.
Yeah? So tell me what will be the answer? Plus answer will be mx times 1 minus x square to the power minus m by 2 minus 1. Yes?
Yes, sir.
So this will be mx times 1 minus x square to the power minus m by 2 minus 1. This is the first derivative of this and times v dash x. Yes?
Yes, sir.
Okay. So ये जो हमने लिया है ना बच्चे, we have taken a dy dx of this particular term. Happy everyone?
सही है सर.
Yes. Now we take a dy dx of this term also. ठीक है ना? So let us do it. Okay, now means I think in 2 breaths we can do it. Oh, this is slightly difficult. So since this is slightly difficult, maybe I will just write it for you. Jing jing. We okay. No, okay, let us do it. Come on. So क्योंकि ये आपको थोड़ा सा मुश्किल लग रहा है ना बच्चे, तो हम ये -1 यहां से हटा देते हैं और इसको 1 minus x square रख देते हैं, because it was slightly heavy. है ना? And since ओके, ठीक है. और अभी इसका एक बार करके देख लेते हैं प्लीज. सो इसको देखें हम पहले. इसमें हम क्या करें, इसमें हम mx vx को एक फंक्शन ले लेते हैं और 1 minus x square by 1 minus x square minus m by 2 minus 1 को दूसरा फंक्शन ले लेते हैं. ठीक है. सो पहले हम इसका डेरिवेटिव ले लेते हैं 1 minus x square to the power minus m by 2 minus 1. तो इसका डेरिवेटिव कितना होगा, माइनस m by 2 minus 1. Oh no 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 plus 1, because माइनस साइन हमने ऑलरेडी कॉमन ले लिया है ना?
यस सर.
सर सही है सर.
अरे क्लास खत्म होगी जी.
पता नहीं यार, सर तो दिख नहीं रहे.
ओवर हो गया. अभी हम सीडी की.
ओवर
नहीं
होगी
क्या?
क्लास.
ओके ओके.
देवेंद्र.
हाँ बॉस.
अच्छा जादू हो गए. रजत.
कूलर की हवा
नींद में है बॉस।
कूलर आगे पड़े हो कर रहे हो।
रिकॉर्ड हो रही है क्लास।
कौन देखे रिकॉर्ड में?
चलो दूसरी में चलो।
चलो